Imagine that you have a friend called Bob who lives on the other side of the world and you need to send him an important message through the mail. Let's say this message contains your newest top secret brownie recipe and you don't want anybody else intercepting your mail and reading it. Knowing that mail gets handled by a lot of people in the process, you decide to write your letter in some secret code that only you and your friend can understand. This process of transforming plain text into unreadable code is known as encryption. When your friend receives the letter, he's able to read your message by decrypting your secret code. This process of writing or solving secret codes is called cryptography. Cryptography comes from the Greek word kryptos, meaning hidden, and graphene, which translates to writing, making it hidden writing. Cryptography has been around for decades. The need to conceal messages has been with us since we moved out of caves, started living in groups, and decided to take the civilization idea more seriously. As soon as there were different groups of tribes, the idea that we had to work against each other surfaced, and rank, violence, secrecy, and crowd manipulation became priority. The earliest forms of cryptography were found in the cradle of civilization, which comes as no surprise to Egypt, Greece, and Rome. As early as 1900 BC, Egyptian scribes used hieroglyphs to hide the meaning from those who did not know the meaning. The Greeks' idea was to wrap a paper or leather around a stick and then write the message on the material, then remove the paper and have unreadable words. The Roman method of cryptography was known as the Caesar shift cipher. Their method used the alphabet to shift the letters in the text, which made the text unreadable. The receiving group would then shift the letters back by the agreed upon number and decipher the message. As cryptography evolved, the invention of complex mechanical and electromechanical machines provided more sophisticated and efficient means of encryption. Such machines were heavily used by the government during World War I and World War II to facilitate safe communications. Today, cryptography plays a major role in people's life as it helps facilitate safe banking, online shopping, hard disk encrypting, and other privacy-preserving applications. There are two basic methods for encrypting information, which are symmetric encryption, also called secret key encryption, and asymmetric encryption, also called public key encryption. Symmetric encryption is the oldest and fastest technique. A secret key, which can be a number, a word, or just a string of random letters, is applied to the text of a message to change the content in a particular way. As long as both sender and recipient know the secret key, they can encrypt and decrypt all messages that use this key. The problem with secret keys, aka symmetric encryption, is exchanging them over the internet while preventing them from falling into the wrong hands. Anyone who knows the secret key can decrypt the message, so one great solution to this is asymmetric encryption. In this type of encryption, there are two related keys, a key pair instead of a single key. A public key is made freely available to anyone who might want to send you a message. The second, private key, is kept secret so that only you know it. Any message, be it text, binary files, or documents that are encrypted by using the public key, can only be decrypted by applying the same algorithm but by using the matching private key. The opposite is also true. Any message that is encrypted by using the private key can only be decrypted by using the matching public key. This means that you do not have to worry about passing public keys over the internet, since the keys are supposed to be public. A problem with asymmetric encryption, however, is that it is slower than symmetric encryption because it involves more complexity when encrypting information.
Today, cryptography has evolved to be an extremely powerful tool for not only the government, but for the public as well. Phones, computers, and other devices you are using daily have the latest encryption built into them. This means most phones will not be able to give out information such as personal data, regardless of whether law enforcement present a valid warrant or court order. Recently, there was a shooting in San Bernardino, and the shooter's phone was seized. Due to the encryption on the phone, FBI agents were not able to access his information. FBI agent James Comey says that it affects cops, prosecutors, sheriffs, and detectives trying to make murder, kidnapping, and drug cases. Encryption is generally enabled by default on devices. It is usually end-to-end encryption, something that requires a key to decrypt it, or nobody else can read it, not even the service provider such as Apple. A possible solution to this are backdoors, which provide a way to access a computer system or the data it contains, but it has its drawbacks as well.
So how can we offer secure and, if required, anonymous communication technologies to good people while allowing this protection to be removed if bad people also use them? Is it really worth it?